Okay, welcome to the quick review of Lecture 2 of Advanced Research Methods. This video is on basic terminology and concepts. So let's start with the definition of population. A statistical population is a set of entities concerning which statistical inferences are to be drawn, and often based on a random sample taken from the population. So there might be some subsets of the population which are known as subpopulation, and if different subpopulations have different properties, the properties and response of the overall population can often be better understood if it is first separated into distinct subpopulation. So population represents the whole set of observations which are available and about which statistical inferences are to be drawn. Now, statistical inference of the population is drawn based on the sample. So what is a sample? In statistics, a sample is a subject chosen from the population for investigation, and a random sample is one chosen by a method involving an unpredictable component. So this means in case of random population, every element of the population would have equal opportunity to be selected into the sample. Sampling is a method based on which we select the desired number of observations from the population. So there are different sampling techniques. For example, there is a simple random sampling, and in a simple random sampling of a given size, all such subsets of the frame are given an equal probability. So this means that each element of the frame thus has an equal probability of selection. And furthermore, any given pair of elements has same chance of selection as any other such pair, and this minimizes bias and simplifies analysis of results. So this means that in simple random sampling, the technique is that we give equal opportunity or equal probability to each and every element of the frame to be selected into the sample. So this is simple random sampling. Another method is systematic sampling. In systematic sampling, we first of all arrange our data in ascending or descending order in accordance with the variable of interest, and then we select every kth element. Now how we calculate the kth element? It is calculated based on this simple formula: population size divided by sample size. Now, for example, our population size is 100 and our sample size is, say, if we want to select 20 observations out of the population of 100, so this means that kth value would be 100 divided by 20, this means 5. So when we arrange the data in ascending or descending order, we can select every fifth element from the population to become the part of sample. So the sample would be selected based on the selection of every fifth element of the population. So this method is known as systematic sampling. Another method is stratified sampling. So this is based on the concept of strata. Now, stratified sampling is adopted where the population embraces a number of distinct categories. The frame can be organized by these categories into separate strata. For example, in a business department, there are students studying in different specialization. They are doing different specializations. For example, certain students are doing specializations in finance, some others are doing specialization in management or in some other. So every group based on their specialization can be categorized as stratum. So this means that in a population there might exist certain distinct categories based on certain common characteristics. So if this situation is present in the population, so this means that we can make strata in our population. Each stratum is then sampled as an independent subpopulation, out of which individual element can be randomly selected. So this method is known as stratified sampling. In contrast to the stratified sampling, there is a cluster sampling. So sometimes it is more cost effective to select respondents in group or in clusters. So clusters, if there are clusters in the population, so we know that every cluster is similar to any other cluster. So if we have clusters in the population, we can select on random basis. Suppose if we have 10 clusters in the population, so we can randomly select 2 or 3 or 4 clusters out of the total cluster present in the population. So this would be the method which is known as cluster sampling. So sampling is often clustered by geography or by time periods, and it is mentioned here that nearly all samples are in some sense clustered in time. So in cluster sampling, if there are clusters in the population, we can select few of the clusters and we can leave the rest of the clusters. But we cannot do this in stratified sampling, because in stratified sampling, if there are stratas, each strata is distinct from any other strata, and we need to draw independent sample from each and every strata. But in cluster sampling, we can leave few of the clusters and we can select some other clusters to make up the sample to take the sample from the population. Another method of sampling is known as quota sampling. In quota sampling, the population is first segmented into mutually exclusive subgroups, just as in stratified sampling. Then judgment is used to select the subject or unit from each segment based on a specified proportion. For example, an interviewer may be told to sample 200 females and 300 males between the age of 45 and 60. So if we have a desired category or quality of the sample, that we want to select at least 200 females and 300 males, and the age is also specified that their age should be in between 45 and 60, then this means that we shall focus only 200 females and 300 males and not more than this value. So this is something like quota sampling. Another is convenience sampling. If we have less time and we cannot spend much cost, can adopt a non-probability sampling technique, which is known as a convenience sampling. And in convenience sampling, sample is drawn from that part of the population which is close to hand. Means if you want to collect, if you want to distribute a questionnaire and you have very less time, so what you can do that you can take the response of the people which are very near to you. So that is a population is selected because it is readily available and convenient. So based on the availability and convenience, we can do the sampling which is known as convenience sampling. Now let's talk about types of data. There is one type of data which is known as cross sectional data. So it consists of a sample of individuals, households, firms, cities, states, countries, or variety of other units taken at a given point in time. So for example, if I collect the data of different cities of the country for a given period of time, for example in 2010, if I collect the data from for 2010, if I collect the data of different companies, so this would be a cross-sectional data, because time is specified and there are different variables for which I am collecting the data at this specified time. So this is a cross-sectional data. In contrast to the cross-sectional data, there is a time series data. In time series data, there is only one firm, there is only one variable, the data of which is collected over a given period of time. So if I collect the data of one company over a given period of time, means for example for 2001, 2002, 2003, 4 and so on up to 2010, so this would be a time series data. So examples of the time series data include stock prices, money supply, consumers price index, gross domestic product, and automobile sales figure, etc. You can make out a couple of more examples for that. So this is a time series data, that for a given variable we select the information for a long period of time. So this is a time series data. Another type of data is pooled cross-sectional data. This means if we add up the time series and cross-sectional data into one data set, this would become a pooled cross-sectional data. So in a pooled cross-sectional data, we say that we adopt it to increase our sample size, and what we do that we draw random sample in each year. For example, if we have 5 years, say 2003, 4, 5, 6 and so on, so what we do that in every year we draw a new sample and we select a different household for study, and this method is adopted to increase the sample size. So now, because random samples are taken in here, it would be a coincidence if the sample household appeared in the sample during both years or repeatedly in different years. So this is the quality of the pool data which make it distinct from the panel data. What is panel data? A panel data is a set consists of a time series for each cross-sectional member in the data set. Now the key feature of panel data that distinguishes it from the pooled cross-sectional data is the fact that the same cross-sectional units are followed over a given period of time. So in pool data, what we do, we collect a new sample every year for study, but in panel data we keep the same household during the given period of time. So this is a panel or longitudinal data. So what is a statistical inference? In statistical inference, it is a process of drawing conclusion from the data that are subject to random variation, for example observational errors and sampling variations, and more oftenly the terms statistical inference, statistical induction and inferential statistics are used interchangeably. So this table gives a short detail of the difference of terminology between the population and a sample. So normally for a population we use Greek letters and capital letters, and for sample we use Roman letters or small letters. For example, mu represents the mean of the population. On the other side, x bar refers to the sample mean. If sigma refers to the standard deviation of populations, this small s refers to the standard deviation of a sample, and so on. There is a list of all these randomly selected population parameters and randomly selected sample estimators. And there is again some terminology used for dependent variable and independent variables. For dependent variable, we say that it can be called as explained variable, it can be a predictant, it can be a regressant or response or endogenous or outcomes or control variable. Now on the other side, independent variables can be called as explanatory variables, predictors, regressors, stimulus, exogenous, covariates and control variables. So there are different terminologies used for the dependent and independent variable. So this is the end of quick review of lecture 2. Thank you for your time.